right. Hello, everyone. My name is Fedor. I'd like to offer a perspective on evolution of version control, mainly focusing on user experience. I had the chance to work on a few products in the space, starting from integration of Subversion in Visual Studio 20 years ago, and recently bringing Jujutsu into VSCode. Originally, I planned to talk about this period, but actually it's more interesting to look at evolution from the start, when version control first appeared in the 1970s, and try to extract patterns, mental models, and things that help us understand the current workflows and what future holds. So here we go, 50 years of version control history in 30 minutes. If you look at the evolution of version control, the fundamental concept hasn't really changed much. It's keeping record of history of versions, what we call main branch these days, and coordinating or controlling work on the next version, draft changes, and so on. If you squint at it, it looks like a palm tree. I think it's a nice analogy explaining to non-technical users. The history is a long trunk, and branches are changes that are work in progress. Even though the concept hasn't changed much, details evolved. So we moved from storing history just for files to the whole projects, to maybe combination of projects in monorepo, identifying versions differently with the numbers, hashes, and so on. But it's still a very simple concept underneath. The way we ship, the way we build software hasn't changed much either. It's still incrementally changing the source code and going in steps. We go through 4 stages normally. We make a change, we discuss it, then we integrate it into existing source code, and then we deliver to users. Maybe in the early days there was a bit more planning at the beginning with waterfall and so on. It became less fashionable, and now we just start making change and go forward. Over time, we shrunk the lead time of the whole process from years to minutes. So in the early days, delivery would take maybe annually in form of a physical box. Then we moved to downloads from the websites, and now we ship functionality to users directly. They can access the website. Discuss and integrate stages and make stage also evolved over time, but we'll see that there is still some frictions and stuff to improve. So let's look at the evolution quickly at roughly allocating these 2 decades. So I know that some products started earlier, but that's approximately what when they were popular. In 1970s, we've got Unix and compilers. That really created the market for software. So standardization of computers and operating systems enabled you to offer your program to someone else to use instead of being just custom to your computer. And compilers enabled us to write programs faster. That created a bit of a mess for people writing program, and they needed something to deal with it. So they invented version control. SCCS was one of the first, and they allowed to store history for individual files and log them to avoid overwriting each other changes. So that's good enough for the beginning. In 80s, we've got more computers with the PCs, democratizing hardware, and local area networks enabled to connect them to each other. So we've got more people using software, more demand for software, pressure to deliver it to users, and early IDEs enabled to build software faster with the edit, compile, and run loop. Larger history, larger projects meant that SCCS was no longer fast enough, and RCS was improvement on that. So it made history access faster by reversing deltas and made locking a bit more practical so that you don't depend on administrators to break the lock if someone goes on holiday. In the 90s, internet changed everything. Now, instead of shipping software physically to users, you could deploy it on your website and allow them to download. So there is now demand for software to be released more often and built quicker, and the project become larger. With scripting languages, also more users are able to write software because it's easier, and people start collaborating on projects over internet. For that, RCS is no longer good enough. It's designed for local computers. So CVS was built as an improvement or RCS, essentially wrapping it in a client-server architecture. Also, locks were the bottleneck. Locking a file when you have a team of 100 people is no longer acceptable. So CVS moved to optimistic merge model where you start editing the file and you deal with potential conflicts afterwards when you try to commit it to the repository. In 2000s, we got cloud that simplified deployment. Instead of waiting for a few days to buy a computer, you could just rent it quickly and deploy your software. Again, more pressure to build and deliver it sooner. With open source movement and package managers, building programs became easier. You could reuse a lot of existing code. Again, projects getting bigger, more people collaborating. CVS started getting not sufficient for that. One of the problems was that if you start changing multiple files, you commit them and commit breaks in the middle, you would corrupt the repository. Subversion fixed some of the problems with CVS, so it was intentionally an evolution. And it changed underlying storage, it introduced atomic changes, so you either commit all files or nothing, and it introduced the ability to work with branches. Not as convenient as in Git, but something that is doable. In 2010, containers standardized deployment environments, making it even easier to deploy software. You just build a container and ship it to your server, and no longer problem, it works on my machine only. With Stack Overflow, it became much easier to solve technical problems that you encounter on the way. Again, writing programs became more accessible to people and more projects happening in the world. So Git has became dominant in 2010s, and it has multiple improvements over Subversion, but just to highlight a couple of them, I think speed that you can have with access to your project was one of the main ones, and that's thanks to keeping all the history locally. With Subversion, it was quite frustrating to wait for seconds or minutes to do any operation, and you had to have connection to the server. With Git, you were free to look at the history status and so on. And branches became much more practical. So with Git, you could work much longer independently, building up changes, and then when you're ready, submitting them into repository. So there's a lot of evolution in those decades and improvements to the make, discuss, integrate, deliver loop. We went from annual releases to minutes. If you look at today, the make step is pretty fast. You can just tell the computer what you want, and it writes the program for you, hopefully correctly. In deliver stage, serverless made it super simple. You don't need to manage computers. You just push your changes to repository, and it's online in a few minutes. If you look at discuss and integrate stages, there is still things to improve. When I talk to engineering teams, a few bottlenecks usually pop up. So people are frustrated with the review delays. Anyone had to wait for a week to get their PR reviewed? Yeah, sometimes it's longer. Some statistics shows that it's around 4-6 days on average, with about 50% of that just idle time waiting. And while you're waiting, you're forgetting what you've done and losing all the context. Yeah. Integration toil. When you're finally ready to merge, there is a lot of manual steps. So you need to rebase your changes, try to merge, notice that someone else moved main, rebase again, and so on. Run the test, wait for them to pass, and deal with it. Long-living branches. So branches that Git brought us are blessing and a curse. So you can work independently for longer, but the longer you work independently, the harder is the integration, right? I've seen pretty bad cases. In one example, a team was working on a feature in a branch for 2 years, continuously rebasing. That's a lot of additional work. And when they finished and merged eventually, it was no longer relevant. The market moved. Yeah, that's extreme case. And cognitive overhead. I think we had quite a few talks about difficulty for people to learn Git. Probably no one here struggles with that, but a lot of people in the world don't understand how to Git work, and they just memorize a few commands and hope that they do something correctly. There are multiple solutions that are emerging. Just to list a few, they're not necessarily new. Big tech and some startups have been using them for years, but they're becoming mainstream. So stacked reviews enable to accelerate reviews. Instead of building the whole big change and offering it for review in pull requests, you extract a small part, offer it to review, and keep working on top of that on the next stage. It requires a little bit of tooling to do correctly, and it's maybe error prone with Git, but there are tools appearing to deal with that, for example, Graphite. Merge queues, I believe both GitHub and GitLab offer them, enabled you to simplify the integration. So instead of doing it manually, you just submitted your change to the queue, and it is automatically rebased on other changes and merged if all tests pass. Conflicts as data is a pretty important one. I think it's pioneered by Jujutsu. The idea is that instead of dealing with conflicts right at the point where you rebase, they're stored in the commit tree instead, and you can come back later to them. On the surface, it might be not a big deal, but it actually is, because it enables editing of commits anywhere in the tree, because you can edit commit at the bottom of a chain and automatically rebase everything on top, and you don't have to deal with the conflicts at this point, meaning that all operations on your Git repository becomes not blocking. That's significant simplification. And also from Jujutsu, the idea of graph-based editing. Instead of having different concepts for staging changes, stashing changes, and commits, and so on, you have a single model of commit tree where your working copy is just one of the nodes, and you have single set of operations for dealing with that. You don't need to do stashing, staging separately. Just to illustrate that, I will quickly show a quick video. So here's a visual interface for Jujutsu. You can see history of main on the left, and a few draft changes on the right. Here is the main branch, and that's where we currently are. Oops, sorry. As soon as you start editing any file or create a file, commit is automatically updated, and you can move to another place in the commit tree easily. You don't have to stash. You can start making new changes at this point, or you can move somewhere else. You can move changes around to do your base, maybe create pull request. And if you remember, we changed the same file in this commit, readme, So what happens if we rebase one change on top of another? There is a conflict. But you don't have to deal with it right now. You can jump to another place and come back later if you like. Or you can resolve it at this point. There is flexibility. So with those improvements, user experience and discuss and integrate stage becomes better, but I don't think we are done yet. Here are a few ideas what could potentially improve user experience. For example, think about how we synchronize repositories across machines. Git has been designed for the case where you can have completely or significantly different state of repository on each user's machine for distributed case. That's relevant for Linux, but most people don't use it this way. They store one copy on GitHub and they synchronize continuously, fetching all the changes, pushing their changes. So what if we make this default and assume that everyone has the same copy of repository? There is reduction in cognitive overhead. You don't have to think about difference between machines. And these days, why do we need to push and fetch manually? We are always online. We could do this automatically. In that case, the mental model becomes much simpler. You don't need to think about differences. You don't need to ask other people, have they pushed changes, have they fetched changes? It's always mostly the same for everyone. Think about moving from Word files, Microsoft Word files, sending over email to Google Docs, where everyone is on the same page. So that's one idea. Another thing that we could improve is branches. If you think about reasons for creation of branches these days, it's mostly to push it to GitHub and create pull requests. That's majority of cases. So if you have native concept for that, something like labels for commits where they need review and so on, then users don't have to think about branches. For them, the mental model becomes just a tree of versions that can easily manipulate. That's all they need to know. And just a few simple operations. Move things around, squash two changes together, split them. That's all you need to know about version control. Oh, and one thing about conflicts. So that's still a significant pain point, even if we store them in the commit tree. So why don't we go one step further and resolve them automatically? If you think about majority of cases with trivial conflicts, you open it and you accept combination or doing something pretty much trivial. So if we could do that automatically and still offer ability to go back and change the resolution, that makes the default case for everyone much simpler. So users who are afraid to look at the code wouldn't look at conflicts at all. This makes version control approachable to less technical users. So those are just a few ideas to consider. If we apply them, I think the mental model for version control becomes very simple. It's essentially a tree of commits. I don't know if that's the direction we go with in the future, but in general, I think a good guiding principle is to remove friction for users, make it easy to use version control, make it invisible so they can actually focus on meaningful work. Thank you very much for the attention. Please feel free to reach out. We probably have time for questions. Yeah, that's a great question. So what happens if with continuous synchronization, two people are working on the same branch or on the same commit? There's a variety of solutions, right? So the very simple one is the last change take precedence. With the sufficiently short delay, that becomes like real-time editing, similar to Google Docs. So if you can be in the same file changing the same lines and everyone quickly see your changes. If you're not comfortable with that, you might go in the mode where you don't want to accept external changes automatically, and then you see, okay, this commit was changed on the remote, and now I decide whether I like the new version or I go back to something previous. Does it make sense?
Right.
Okay. Any more questions? Yes, please.
You showed a lot of the history of how the different version controls are killing off the other ones. Do you see anything coming in the future from that research that'll kill Git?
Oh. Yeah, the question is, do I see anything replacing Git in the near future? One thing that I should mention is that the conceptual model we have for version control, Git is very good fit for that. So the object model of commits, capturing the state, and referring to parent or multiple parents is essentially what we have in mind about version control. I don't see a reason why we should move from Git. There is probably minor practical things that we're missing, like change IDs, but that's coming now with Git Butler and Jujutsu adopting that. So I don't think the underlying model needs to change, and everyone is using Git anyway, but there is a lot of improvements in user experience on top of, and that evolution is happening. Yes?
Quick question. So, in the image that you showed us with all the branches on the repository, Jujutsu, I think, how would it look for a very complicated repository where, let's say, there are 100 people working on it and they're pushing and pulling repository?
I'm not showing it on the screen anymore. But the question is, I showed the visualization of commit graph in Visual Studio. How would it look with hundreds of people working and a lot of commits? So here's a bit of flexibility. Most of the time you care about your commits only. So you would filter everything else, filter out everything else. It's still there in your local repository. Your state is consistent and synchronized, but you're only looking at a small part, or maybe even just one sequence of commits. Right. Yeah. And when you are interested in changes from other people, you can filter by users, look at everything if the project is small, but that's not practical for huge repositories.
In that case, how different is it from just using Git, like the command line things?
How different is it from using Git command line? The underlying model is the same. It's still Git repository, and you can use any tool you like. And in principle, you can do everything that new tools like Git Butler or Jujutsu are doing. You can do it with the Git CLI. It's just more steps, more complexity to deal with. It's your choice, but it's good that we have the choice. If default case is simple, but you can always go back to lower level tools and deal with advanced case, that's a nice combination, I think. Thank you. Any more questions? Cool. Thank you very much, everyone.